Welcome to my video lecture on word problems. Okay, you should be doing this after you have after you've done the homework and studied section 2.6. All right, so let's talk about word problems. In your textbook, there is this nice chart from back in chapter 1. So I've taken this chart from chapter 1 and put it here. Okay, so these are just reminders of key words and phrases that mean all of the different operators. So the first column is all those words that can mean addition. Again, be careful with more than, added to, okay, increased by. Be careful with those because in the English language they can mean a little bit different things. Okay, again, same with subtraction. Less, less than, and subtracted from. Make sure you're being very careful with those translations. Multiplication, division, okay, everything that can mean equals. Okay, these are all different. So this is all back from chapter 1, but I thought it would be useful to have it just in case if you want to take a picture or copy it down or have your book open to that page while you're working on these word problems. It's definitely be a good idea. Okay, so there are lots of different types of word problems. So I tried to pick out the 7 most popular types of word problems that you see. So we are going to go over one of each. I'm going to go over one and then I'm going to have you practice one. So of the different 7 types. So we have 14 different problems that we're going to work on. All right, so the first one is just a strict translation problem, okay? They're going to give you the words, you're going to translate it into math, and then you're going to solve whatever equation you end up with. All right, so here we go. Let's find the number. First one, twice the sum. Okay, so twice the sum means I'm taking twice an addition problem. So what am I adding together? I am adding together a number and 5. So there's the first half. Equals. Equals means equal sign. Okay, then we're going to go to the right hand side and that says the difference. We're starting with a difference. The difference is a subtraction problem. And what are we subtracting? We are subtracting 4 times the number and 8. So 4 times the number and 8 is what we are subtracting. So that is the equation I'm looking for that matches the words. This is the hardest part of the whole thing, is getting this equation. Once you get the equation and you have to solve it, not so bad. But just getting this equation is the hard part. This is where you might have to practice a bit. All right, so once you have the equation, you're going to solve it just like we did any other equation in section 4, okay, section 2.4. So you're going to get rid of those parentheses. Make sure both sides are simplified as much as possible. You're going to get all of your variable terms on one side. Remember, get rid of that smaller one. So 10 equals 2x minus 8. You're going to add 8 to both sides. So you get 18 equals 2x, and then you're going to divide both sides by 2. So you get x equals 9. Now, this says the number equals 9. So you really don't have to write it in words because that's actually what the symbols mean. So our number is 9. But here's the worst part. Can we check it? If you have the correct equation when you're starting, then yes, all you have to do is plug it in. But what if you have the wrong equation? You're going to get the wrong answer, which means you're going to take your wrong answer, plug it back into your wrong equation, and it's going to tell you you're right. So you really have to trust yourself and hope that you had that equation translated correctly. Because if you have this translated wrong and you have the wrong equation, you're going to get the wrong answer. All right, so here's one for you to try. So press pause and give this one a try, and then we'll work through it together. All right, welcome back. Here we go. Okay, so 3 times the difference. So 3 times a subtraction problem. And what are we subtracting? We are subtracting a number and 4. So x minus 4 is the same as, okay, that means equals. And then the sum. So there's an addition sign over here because we're adding things together. We are adding together 5 times the number and 8. So 5x plus 8. So hopefully that is the equation that you came up with. And I know for some of you it's a struggle. Keep practicing. That's the only way you're going to get better. There is no magic pill. All right, so we are now going to solve this equation. So get rid of those parentheses. We're going to get rid of our smallest variable term. So I get negative 12 equals 2x plus 8. I'm going to subtract 8 from both sides. So I get negative 20 equals 2x. And then I'm going to divide both sides by 2. So I get x equals negative 10. So there is my answer. X equals negative 10. So that's the first type. Strictly translating, no context, no story, no nothing. Just take the words, change it into math, solve the equation. Example number 2. Okay, another type that's very common is what's called a board problem. You're going to take a board and you're going to cut it into pieces. Okay, it could be a piece of pipe or a piece of rope. You're taking something and you're cutting it into some different size pieces. So sometimes a picture helps. So let me walk through how I solve these and then you can try one. All right, so we are starting with a 28-foot board. So here's my 28-foot board, right? This whole board has a length of 28 feet. Okay, it says I am cutting it into 2 pieces. So I'm putting a cut somewhere. So I've got, this is my first piece and this is my second piece. And I know what happens when I add those 2 pieces together. They have to add up to 28. So I know if I take the first piece plus the second piece, that has to add up to 28. Okay, I know this for a fact, right? Because that's the length of my board. All right, now let's go look at the pieces. Okay, it says we are cutting it into 2 pieces so that the second piece is 4 feet longer than 3 times the first. Well, they're telling me the second piece in terms of the first. I don't know how long the first piece is, so that's my variable. I'm going to call the first piece x. So this is x. So that means in my equation, this is x. All right, it says the second piece is, right? The second piece is, right? Is means equals. Okay, 4 feet longer than. 4 feet longer than means I'm adding 4 to something. Okay, 4 feet longer than what? Than 3 times the first. So 3 times x. So that second piece is 3x plus 4. So down here in my equation, instead of second, I'm going to put 3x plus 4. All right, so there is my equation that I'm looking for. X plus 3x plus 4 equals 28. That's the equation you need to solve. So I'm going to combine like terms. 4x plus 4 equals 28. I'm going to subtract 4 from both sides. I get 4x equals 24. I'm going to rewrite that up here. 4x equals 24. So I'm going to divide both sides by 4, and I get x equals 6. Okay, so I've solved the equation. Now let's go back and answer the question. And this is usually where students mess up, okay? Make sure you're answering the question. The question says, find the length of each piece. Okay, so what's the first piece? Okay, the first piece is just x, and x is 6, so it's 6 feet. And then we're going to go, what is the second piece? Okay, here's the second piece right here. 3 times x, well, the x was 6, so 3 times 6 is 18. 18 plus 4 is 22 feet. Okay, when you check now. If you add up those 2 pieces, is the first plus the second equal to 28? 6 plus 22 is 28, so we're good. We have the 2 pieces. But it's very important that you don't use the check to try and solve the problem. Use the algebra, okay? Remember, this is an algebra class. Everything should be algebra. All right, so the next problem is exactly the same. I just changed the numbers a little bit. So here is your example. So press pause, give it a try, see how you do, and then we'll come back. Maybe you need to go back and rewind and watch a little bit. Go look, listen to that last example again, but give it a try. All right, welcome back. So we have a board measuring 98 feet. So we know the first piece, and we're cutting it into 2 pieces. So first piece plus the second piece equals 98. All right, so it says the second piece is, so it's telling me about the second piece first. The second piece is 2 feet more than 3 times the first piece. And I don't know the length of the first piece. So first piece is x plus, all right, the second piece is, okay, it is 2 feet more, so we're adding 2 to something, then 3 times the length of x, so 3x. All right, so there is my equation that I'm looking for. Hopefully you had the same equation I did. All right, and that's the equation we're going to solve. So we're going to combine our like terms. Then we're going to isolate our variable term. And then we're going to isolate the variable itself. So I get x equals 28. All right, so we have solved our equation, but that doesn't mean we're done. So it's very important. Oh, that's not 28 at all. That should be 24. See, this is why you should always use a calculator, because sometimes when you try to do stuff in your head, you mess up. So 96 divided by 4 is 24. Okay, so we have solved the equation. Now let's answer the question. How long is each piece? So the first piece That's just x, which we know is 24. So it's 24 feet. And then the second piece. The second piece is 3x plus 2. So 3 times 24, and I'm going to use my calculator this time since I messed up before. So 3 times 24, and then we're going to add 2 to that, and that gives us 74. Okay, so at this point, stop. When you add these two pieces up, they should add up to 98. So 4 plus 4 is 8. 2 plus 7 is 9. Okay, so they do add up to 98, so we're good. So that is my final answer right there. The first piece is 24 feet, and the second piece is 74 feet. All right, very similar to board problems are the next type of problems. These are called parts problem, where you're taking something and you're dividing it, you're grouping stuff together by a common attribute. So maybe if I had an algebra class, I'd break it up by the number of students who have glasses versus those who don't. Okay, those students wearing hoodies versus those who aren't wearing hoodies. Okay, so you're going to break it up into two different parts. They often use gender to do this, and I do a small disclaimer in all of my math classes. This is not a sociology class. In math, there are only two genders. So here we go. An algebra class has 27 students. So I know if I take all the females and add the number of males, that is going to add up to 27 students. So there's my class. All right, then it's going to give me some information about the males or the females. So it says the number of female students is, okay, so they're talking to me about females. It is 3 less, so I'm subtracting 3 from something, then twice the number of male students. So twice, and maybe let's use M for males, just to keep it, so plus the number of males, which we just said, we're going to use M for males, equals 27. So there is the equation I'm looking for. 2m minus 3 plus m equals 27. So we're going to solve this equation. We're going to combine our like terms. We're going to isolate our variable term. And then we are going to isolate the variable itself. So we get m equals 10. All right, now we're going to go back and look at the question it's asking us. How many male students are in the class? Right, and we just solved for m as males, so there are 10 males in this class. So there's my answer, 10 males. All right, so notice how I started off with kind of having this equation that's like half in English and half in math. I'm a big fan of doing that, okay? So if you need to, make it half and half English, half math, and then change it all over to math. So the next question, I changed the numbers a little bit, but I made a little trick. So make sure that you read the problem carefully. All right, so here's the problem, same situation. Press pause, try it on your own. All right, let's see how you did. All right, so we have another algebra class. We've got males, we've got females, and there are 23 students in the class. So I know if I take the females plus the males, that should add up to 23 students. All right, it tells me the females is 5 less. Okay, so females is 5 less than 3 times the number of males. Okay, so plus m is males, and that should add up to 23. So there's the equation. Hopefully you have the same equation that I do. So I'm going to combine like terms. I'm going to isolate my variable term. And then I'm going to isolate the variable completely. Okay, so I've solved for my variable, so m equals 7. So that means I have 7 males. But this says, how many students are female? So you needed to plug it in right here where it talked about females. So 7 times 3 is 21. So 3 times 7 minus 5, so that's 21 minus 5, and 21 minus 5 is 16. Okay, so there are 16 females, and if you want to check, 16 females plus 7 males should add up to 23, which it does. So again, make sure that you're answering the question, because very often students will just be like, oh, M is 7, so there are 7 males. Boom, I'm done. Okay, make sure you're answering the question. All right, there are also a lot of geometry problems that show up in word problems, so you will see those a lot. So if you blocked out your geometry experience in high school, I'm very sorry. But we need to make sure that we are working with our geometry. All right, so I even drew you a picture on this one. How nice of me. Okay, an isosceles triangle has 2 base angles with the same measure. So here's the picture, right? They have 2 sides are the same, 2 base angles that are the same. Okay, so I don't know what they are, but we're going to read the problem and see if it gives us any information. All right, so it says if the third angle is, so they're talking about the third one. So they're talking about this one up top first. Okay, so that third angle is 5 degrees more. Okay, so 5 degrees more than what? 5 degrees more than 3 times the base angle. So 3 times, we'll just call it x. So each of these down here is x. This is x and this is x. All right, so I have all 3 angles of my triangle labeled. Now, what do I know about the 3 angles of a triangle? Okay, we talked about this at the very beginning of section 2.6. Okay. The 3 angles of the triangle always add up to 180. So the 2 base angles added together plus that third angle at the top are going to add up to 180 degrees. Okay. That's the equation I'm looking for right there. 3 angles of a triangle add up to 180. So this is the first base angle plus the second base angle plus that third angle at the top. Those have to add up to 180. So that's the equation I'm going to need you to solve. So I'm going to combine like terms. So I have 5x plus 5 equals 180. I'm going to get that variable term by itself. And then I'm going to divide both sides by 5 to get the variable by itself. And I'm going to use my calculator because I tend to make very silly mistakes sometimes. So 175 divided by 5 is 35. Okay, so I've solved the equation. Now we have to go back and answer the question. And this says to find each angle. Okay, now the good news is these 2 base angles are pretty easy to find, right? They're just x. So these are 35 degrees and this one's 35 degrees. So it's just this one up here we might have to do a little bit of math. So 3 times 35 plus 5. Oops, plus 5. So 3 times 35 is 105. 105 plus 5 is 110. So there's my 3 angles. Now, when you're done, make sure, add those up. What should they add up to? They should definitely add up to 180 degrees. If they do not, that means you messed up somewhere. So always make sure you're double checking at the end. So I'm sorry that I'm giving you flashbacks to geometry. All right, so here's a very similar one. It's not an isosceles triangle. All the different angles are different, which means it's called a scalene triangle. So if you want to, press pause, try this one. All right, welcome back. Let's see how we do. Okay, so this one was nice, and it said the sum of the angles is 180. So I know when I add these 3 up, so angle 1 plus, so the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 has to add up to 180 degrees. All right, so let's find out about each of these angles. Okay, this says the second angle of the triangle is, so this one up here, the second angle is 3 times larger than the first. So 3 times, we'll call it x. Okay, so this one, the first one is x. So the second one is 3x. And the third angle is 80 degrees greater than the first. So that means this one down here, this is x plus 80. Okay, so 80 degrees greater than the first. So there's my 3 angles labeled. Let's put them in the formula. So the first angle is x plus the second angle, which is 3x, plus the third angle, which is x plus 80. That has to add up to 180. So that is the equation. Hopefully you have the same one that I do. Okay, we're going to combine our like terms. So that gives me 5x plus 80 equals 180. I'm going to isolate my variable term. So I get 5x equals 100. I'm going to isolate my variable by dividing by 5, and I get x equals 20. And this problem just said find the measure of the first angle. So the first angle is just x, and x is 20 degrees. So notice I've got a label. All right, hopefully you did all right, okay? This might require you to practice, especially if it's been a couple years since you've seen some geometry, so you definitely might need to brush up. All right, the next type of example is also a geometry problem. It has to do with perimeter, okay? And we did some perimeter problems back when we did section 2.6, so this might be a little repetitive, but it's important that you see it again. Okay, find the length of the rectangular garden with a perimeter of. So rectangle, perimeter. We automatically know we're going to start with P equals 2L plus 2W. All right, it tells us the perimeter is 94, so I'm going to replace the P with 94. All right, then it says the length is 5 meters more than the width. So instead of L, okay, so I'm going to rewrite this with L in parentheses. Okay, L is 5 meters more, so I'm adding 5 meters to the width. So the width is W. So notice I have this nice pretty equation, one variable. You should just have W's or just have L's at this point. So make sure that you don't have multiple variables. All right, so I'm going to solve this equation first by getting rid of those parentheses, and then I'm going to combine my like terms. So there is my simplified equation, 94 equals 4w plus 10. I'm going to isolate the variable term, so I get 84 equals 4w, and then I'm going to isolate the variable itself. So that's 21 equals w. Okay, so I've solved the equation. Now let's go back and answer the question. They want you to find the length of the rectangular garden. So the length we knew was w plus 5. So w plus 5 is 21 plus 5, which is 26, and this is in meters. So there's my label, 26 meters. All right, so that looks kind of similar to one we did earlier in section 2.6. All right, so here's a very similar problem. I would like you to try it. Okay, so press pause and give it a go. All right, so here we go. Welcome back. The perimeter of a rectangular field. So perimeter equals 2 lengths plus 2 widths. Always start with that formula. All right, the perimeter is 196. So I'm going to replace the P with 196. Find the length and the width of the field if, okay, so I need to find both at the end of the day. If the length measures, okay, so they're telling me about the length. So instead of L, I'm going to put a set of parentheses. And the length is 8 feet longer, so I'm adding 8 to twice the width, so 2w. So there's the equation I'm looking for. Hopefully your equation and my equation match up, because this is the equation I need to solve. So first thing I'm going to do is I'm going to distribute to get rid of those parentheses, and then I'm going to combine my like terms. So there is the simplified equation that I'm looking for, and then I'm going to subtract 16 from both sides to isolate that variable term, and then I'm going to divide both sides by 6 to isolate the variable itself, and 180 divided by 6 is 30. All right, so W equals 30. So that tells me the width of the field. So the field width is 30 feet. Okay, and then I need to find the length, right? Because it wanted us to find both. The length was, remember the length was right here, 2W plus 8. So 2 times 30 plus 8. So that's 60 plus 8, which is 68 feet. So there's my two dimensions. The width is 30 feet and the length is 68 feet. So again, you might need to practice some more. That's perfectly all right. All right, the last couple of examples use inequalities. So it's, since we had a chart for the equalities, I decided to add in a chart for the inequalities as well. So here's the symbol, and then here's what the words might say. Okay, and then there's some examples in words, and then here's some translations. So this chart, again, might help you with these next couple of examples. So you might need to keep this out. It's also in your textbook, which is nice, but here you have it. All right, so example number 6 is having to do with finding averages. Now, I know a lot of you have probably had to find averages in your classes before, so this might be something that you've seen before. So this says Sean has scores of 72, 81, and 96 on his 3 algebra tests. What score must he get on his 4th test so that his average is at least an 85? So this is the important thing right here. We want his average to be at least, okay, we want the average to be greater than or equal to 85. Now, how do I find an average? Okay, to find an average, you're going to add up however many things that you have and divide it by that number. So in this case, we're talking about a 4th test. So there's 4 tests that have happened. So we're going to add up those 4 tests and divide it by 4. All right, so let's talk about those 4 tests. He had a 72 plus an 81 plus a 96 plus the 4th test. And this is the one we don't know about, so that's going to be our variable. That's going to be our x. And this is something you can do in this class as well if you need to find your average on your test scores, because remember, your test scores are the most important thing. They weight the most for your grade for the semester. All right, so first thing I notice is I have a fraction, so I'm going to multiply both sides by 4 because I want to get rid of that. Get rid of any fractions that I have. So I have 72 plus 81 plus 96 plus x. And I'm going to add all those together just to simplify that side up a little bit. So 72 plus 81 plus 96 is 249. So I have 249 plus x is greater than or equal to. And then on this side, I'm going to take 85 times 4, which is 340. And then the only thing I have to do to get the x completely by itself is to subtract 249 from both sides. So I get x is greater than 91. Okay, so what does that mean as far as his fourth test? X, which is the fourth test, has to be greater than or equal to 91. So he needs, on that fourth test, he needs at least a 91%, okay? He cannot get below a 91%. If he gets below a 91%, he will not keep an 85 average. All right, so same situation. I'm just going to change the numbers and let you try. All right, so if you'd like to, go ahead, try, press pause. I'll see you back in a second. All right, so this is the same situation, only this time it's biology class. She wants a B. So we need to get at least an 85. So we want the average, again, the average to be greater than or equal to 85. Okay, and the average, remember, we've got 3 tests, and we're talking about a fourth test. So we're dividing by 4, and those 4 tests are 78 plus 84 plus 90 plus that fourth test that we haven't taken yet. So that's going to be our x. All right, so there's the equation. Hopefully you have the same equation I do, the same inequality that I do. Okay. Then I'm going to multiply both sides by 4 to get rid of that fraction. So I get 78 plus 84 plus 90 plus x is greater than or equal to, that is 85 times 4 is 340. I'm going to add all these numbers up. So 78 plus 84 plus 90 is 252. So 252 plus x is greater than or equal to 340. So to get x by itself, I need to subtract 252 from both sides. So 340 minus 252 is 88. Okay, so there is my inequality. Now we have to say, what does that mean in words? X is greater than or equal to 88. So her fourth test has to be greater than or equal to an 88. So she needs at least an 88% on that fourth test to keep her average of 85. All right, so averages, another place that you see inequalities in solving equations. All right, and the last example that's very common is a budget problem, and we discussed one of these back in section 2.6. All right, so let's just practice a little bit more with budgeting. Okay, so a park charges $15 per child plus a cleanup fee of $60 for birthday parties. And if you've ever thrown a birthday party for a kid, it's totally worth it to pay $60 to have somebody clean up after your children. Okay, so Emma can spend no more than $240, right? So she has to spend less than or equal to $240. That is her budget. She cannot go over $240. All right, she is spending her money. The park charges $15 per kid, right? So 15 times, P for person, I don't know, child, you can use a C, whatever you want to use. Okay, plus she has to pay that $60 cleanup fee. All right, so there is the equation I'm looking for, the inequality I'm looking for. Now I need you to solve for P. So the first thing I'm going to do is I'm going to isolate the variable term. And then I'm going to divide both sides by 15 to isolate the variable. And 180 divided by 15 is 12. All right, so P, the number of kids, is less than or equal to 12. So how many kids can I invite? Okay, at most, I can invite 12 children. Okay, but if I go 13, it's too much. Okay, I could go 11, I'm still spending less, that's fine. I'm under my budget, that's fine. But 12 is the absolute maximum number of kids. So you could put 12 children maximum, that's fine too, that would still be the same. So in words just has to make sense in context to the problem. All right, so now it's your turn to try, and you are going to budget a wedding reception. All right, here's your example. Go ahead and press pause, give it a try, and then I'll see you back in a second. All right, so in this case, their budget, they have to spend no more than $1,000. So you're spending less than $1,000. And on this wedding reception, we are spending $15 per person plus the cleanup fee of $100. So there is the inequality that I'm looking for. Then I'm going to subtract 100 from both sides to get that variable term by itself. And then I'm going to divide both sides by 15. And I get P equals 60. So, oh, whoops, not equals, less than or equal to. Sorry about that. All right, so that means how many people can they invite? At most they can invite 60 people. Okay, anything over that, they're going to go over their budget. All right, so those are the 7 most common types of problems that you're going to see. So you are now free and clear to go practice the extra homework in MyMathLab that says word problems. So feel free to practice those, and then we will be all set for the Chapter 2 test.